Good morning, everyone, and welcome to day 2 of DC Fintech Week, or as we like to call it, Finchella. And this is the application layer presented by Gibson Dunn. I'm Jeff Steiner. I'm a partner at Gibson Dunn, and I'll be your MC for the day, and I'll moderate at least one panel. So yesterday we laid the groundwork exploring infrastructure, innovation, and policy frameworks shaping FinTech's future. Today, we're going up the stack, and we'll see how these technologies are actually being built, governed, and brought to market, from AI-native products to the evolving playbook for governance and the rise of the one-person unicorn. It's a day about application, where big ideas meet reality, and where theory turns into code, compliance, and creativity. And we're going to kick things off with 2 fascinating demos that show exactly what that looks like in action. So we're going to start by pulling back the curtain on AI itself. Everyone talks about AI models and apps, but very few understand the infrastructure that makes that all possible, from chips to data centers to APIs. To help unpack this, we have Assistant Professor David Hyde of Vanderbilt University. David has been on the cutting edge of research in how the back end of AI systems really work. Please join me in welcoming David Hyde.
All right, thank you so much, Jeff, for the warm intro. I'm super excited to talk to everybody today about AI. And look at that, we've got slides working as well. Fantastic. Awesome, so let's jump right in. So one of the things that I love to highlight about artificial intelligence that a lot of people don't necessarily realize is AI is not new. AI is something that's been going on literally 75 years as of 2025. Alan Turing, one of the original godfathers of computer science and certainly AI, the Nobel Prize in Computer Science is the Turing Award named after this guy. He was working on this stuff in 1950, publishing papers. If folks have ever heard of the Turing test, this was his paper that published the Turing test, the idea of if we had a computer, hypothetically, that could give you answers, that could converse with you, that could act like a real person, could you tell whether something was actually a person behind the machine talking to you, or was it something artificial that resembled intelligence? So again, far, far before the era of ChatGPT and all these things, this is already something on people's minds. So one of the big things I want to cover is sort of what changed, right? 75 years ago, shortly after World War II, we already had ideas of, well, wouldn't it be cool if we had systems like this? And there was a lot of early math as well in the 40s and 50s being developed that laid kind of the groundwork for the neural network models and stuff of today. So why didn't we have all this stuff in the 50s? Why has it taken us so long to kind of get here? And I argue it's 3 main points, okay? So bear with me. We'll try to get through all 3 here. The first one, I'm a nerd at heart, so math is extremely important to the development of what's gone on these past few decades. One of the interesting points that you need to really kind of be deep in the weeds to understand the subtle differences here is that there are all these different terms people throw about. People talk about AI, machine learning, deep learning, whatever. And these are actually subtly different things that are tied to the development of the math that happened over the years. So originally, back in kind of like the 50s, 60s, 70s, artificial intelligence was kind of the big catchphrase. And what original true AI was really all about was trying to teach computers rules. If you think about playing chess or something like that, right? Like a chess piece can only move in certain directions or whatever. And so if you're writing a computer program, can you, encode all of those different rules for how chess pieces can move and thereby constrain the program to only generate, valid sequences of chess moves? So this kind of idea. So original AI was about, can we define enough rules and, regulations and policies, if you will, for how a system should behave so that we can create some system that only generates sort of valid things or understandable things. So that was the initial effort, but it turned out to be too hard. Like people in the real world, it's too complex, right? If I say, give me a generic rule for every sentence that you might want to invent with your chat GPT or whatever, too complicated. So people moved into machine learning. And the idea of machine learning was, okay, give up on all the rules and logic and formalism and philosophy and stuff like that. Just give me data, okay? I have a bunch of data points. I know, like, I want to do some clustering task or some labeling task. Maybe I want to determine, which cities are affluent and which ones aren't, and separate them somehow. And so all these mathematical models were developed to say, given a big set of data that you collect somehow out in the field, how do you do something with that data? And so that worked really well. Actually, perhaps ironically, the U.S. federal government was one of the cutting edge, leading technological innovators in early machine learning. The U.S. Postal Service specifically was one of the first large groups to really go in on machine learning back in the day. They had, you mail a letter, and all the letters go through the central processing stations of the postal system. And they had these huge cameras for the 60s or whatever that would scan the envelopes and figure out what zip code was written on the envelopes, right? And so they use these classical machine learning models to do digit classification and say, this is the 3, this is a 7. And so they could save a bunch of labor in figuring out and automatically routing all the mail to the right place. So that was all well and good. But recently, and actually the math is older, but this recently kind of became possible, people have really leaned into deep learning. And deep learning is really where we get into Gen AI and large language models and all this kind of stuff. It's all deep learning stuff. The main difference between machine learning and deep learning, if we're being really technical, is deep learning allows you to do stuff with nonlinear functions. So what's an example of a nonlinear function? How about, the value of the NASDAQ, something like that, right? Pick something from finance, any type of quant finance signal, highly nonlinear. Okay, it's not just a simple line or a set of lines. And so for a long time, people were only able to kind of do linear things, and now we can do arbitrarily crazy nonlinear things. And so these were all mathematical developments. So super important, the work that really abstract mathematicians did over the years. Another one, big category of advancement that's a little easier and more tangible to grasp is the data side of things, right? And so, as I mentioned, machine learning and deep learning models depend on having a bunch of data. You just throw a bunch of data at all these mathematical models and equations, and out comes some AI system. That's sort of the idea here. But to do that, you need a ton of data. Fortunately, 90% of all data ever created, every photo, email, text, video, any piece of data in the world, 90% of it's created in the last 2 years. It's insane. There's truly exponential growth in data. And concurrently, with all that data being generated, we have storage costs like hard drives and things like this also getting bigger and exponentially cheaper as well. So fortunately, all these companies in the storage space have sort of kept up with the massive increase in data that's being created. And if you think about it, like this data problem is just getting crazier. Your camera in your phone is getting better and better every generation, right? So all of your photos and videos that you're taking take up more space. Everything is on track to create more and more data. And largely this is happening now in the cloud as well. So classical storage providers now, some of the cloud hyperscalers, AWS and friends, largely contributing to the rise in data. And then lastly, my third category, what sort of enabled AI and broad to this point? I'm going to be cheeky and say it's video games. It's really hardware, but the hardware in particular that's enabled AI is hardware that's come from video games. So if you look, if you have ever played video games, if you have kids that have played video games, over the years we've gone from sort of Pac-Man in the 80s to video games that are as lifelike and as many special effects as you want, right? So the quality of graphics in games has increased drastically, and that's a huge market, right? People love this. The hardware, the technology that's enabled that rise in computer graphics is GPUs, graphics processing units, okay? So this is the thing NVIDIA is worth $1 trillion for, right? So for 20 odd years, NVIDIA was hanging around the Bay Area just serving video game customers, okay? And that was sort of the thing. Now the trick is thinking deeply about how does the math of computer graphics work? If you want to draw or create some explosion or shoot a gun or something in a video game or whatever, how does that actually work? Turns out it's a bunch of math, okay? So there's a bunch of code and math happening behind the scenes to render those video games. There's a guy, a Stanford PhD by the name of Ian Buck, who's now VP at NVIDIA. But he was a big video game guy, and circa 2005, 2006, he was in grad school playing video games, doing a little research, whatever, thinking about GPUs, and he realized, well, hey, the math that powers video games is actually like a whole bunch of linear algebra. It's matrices and vectors. And if anybody's sort of a math person in here, data, when you collect a bunch of data in the field for like a machine learning model or something, for example, looks like a matrix. It's a bunch of numbers and a big, giant grid of numbers in a data. And so what Ian Buck realized was, hey, like we can actually use GPUs to just do math. Like we don't need to draw pretty pictures at the end or make a video game. These GPUs are just really, really fast at doing the kind of math that's really useful for what turns out to be machine learning and data science and all these kinds of things. So he invented this language called CUDA, which is used for programming GPUs to do sort of arbitrary computation, including machine learning and deep learning. So thanks to video games and people's interest, we ended up with this hardware that serendipitously, truly, turned out to be exceptionally useful for AI. Okay, so those are really the three big innovations that got us to where we are today. What hasn't changed? Okay, some things have stayed the same. This is a photo from like an IBM machine in the 70s being used for AI. And now we have Jensen in front of a huge AI data center there or whatever. So AI still demands a ton of compute, okay? Just as it did in the 70s. We had the PC revolution where computers seemed to get a lot smaller, right? But in terms of cutting edge AI, no, actually the computers stayed gigantic. So you still need a warehouse full of compute. And in fact, the power demands have gone up. So this is just as a percentage of data center use, AI power is increasing a bunch. And if you look at sort of the biggest AI data centers, the power demands are actually drastically larger than they were back in the day. This is enough to power a small city. And sort of at the going rate by circa 2030, the strain on the grid just from AI alone is sort of like 20% of like the entire consumer usage of power in America. So this is perhaps troubling, but perhaps an opportunity as well, right? So this is one of the big concerns in AI. Like, in order to keep driving AI innovation, perhaps you've seen the headlines in the news, America and countries around the world are literally turning on or creating new like nuclear power plants. Like we're turning on 3 Mile Island again, which had a minor nuclear meltdown and a big historically bad incident with all that back in the day. But because Microsoft needs more electricity to run their AI data centers to train more models, literally turning back on 3 Mile Island and all these kinds of things. Super interesting. So it's been a historically great time to invest in uranium, and things that power nuclear power plants. And surprisingly, like because of the extreme strain on the grid, you're seeing some interesting political things as well. Historically, all these environmentalist activist groups and stuff have vehemently protested being anti-nuclear or whatever. And there's this growing realization that just the reality of the market is that there's going to be such a demand on the grid that like you need to actually save these nuclear power plants or build more nuclear and invest into that as a component of your energy strategy in order to just meet the demand. Like just building solar, just building more coal, like nothing on its own is going to be fast enough to keep up the pace that AI power demand is growing with. Okay, so I mentioned GPUs. This is the big thing with NVIDIA, right? There are a couple other chips that are sort of worth mentioning, right? So there's still innovation on the hardware space as well. So NVIDIA, while it's definitely like the dominant player in the deep learning space right now, there are a bunch of folks trying to do other stuff. At a high level, this is a fact of life, the more specialized your thing is, probably the better it's gonna do. This is just, applies to anything in life, but certainly to computer hardware as well. So you can go from GPUs, which can do general different sorts of things, all the way to application-specific integrated circuits, ASICs, which are little pieces of hardware made to do one particular thing. So Google has their tensor processor unit in the bottom left there. There's other startups, Cerebras, for example, in the bottom right, has this very big chip that they're making. And these are things that are specifically just meant for AI. So people have looked at NVIDIA GPUs and they're like, that's really wasteful. Like if we want a chip that only can do AI and can do nothing else, we can actually cut out a bunch of the cruft and eliminate a bunch of the circuitry and make chips that are faster or cheaper or more energy efficient that can only do AI things. So that's one thing to note. There are a lot of players trying to innovate in the hardware space right now. Okay, so that's sort of the hardware space and kind of what's going on there. But I want to touch on what's really happened in the last 3 or 5 years, because there's been this other explosion, right? Like we've been getting more data, better GPUs, or whatever, for 20 years or whatever. At this point, what's really changed since pandemic times or whatever that this new wave of AI tech has really taken off? One of the big things is with large language models. And large language models are just a type of deep learning model. So they're just a sort of a better version, if you will. And one of the key innovations here is this transformer architecture. So a transformer, just think of it as a type of neural network, a type of deep learning model. It's a better mathematical construction to make these models work better. And generally speaking, the way that all these large language models work, aside from having some better math kind of under the hood, they're all doing next token prediction or next word prediction, if you will. So they might not be doing text, they might be doing other things, pictures or whatever. But for example, in a text model, really what an LLM is doing is you give it some sentence, you give it some prompt or whatever, and it has some super complicated model under the hood that says, given this prompt, what's the next word I should spit out? So it looks at this and this is, okay, land, and then it'll look at the next word and the next word and the next word. So it does this over and over and over internally and can spit out some huge sentence or paragraph or whatever. So it's really miraculous that this thing works as well as it does, but it turns out it does, and this is what's going on. And to sort of just explain that a little bit, there's a picture of a transformer, which we don't need to talk about, but just to throw one little mathy thing on the board here, regardless of the architecture you're using, whether you're using a transformer model or a convolutional neural network or any type of neural network, doesn't matter. You don't need to know any technical words. Every single neural network looks like a function, okay? It's f of x, and you have some parameters in your model. So you have some input, which might be like the prompt to your ChatGPT or whatever that you type in. You have some parameters of your model, and you have this magic function that takes all your parameters and your input, and it gives you some output. It gives you an image of a cat, or it gives you your next sentence that you're trying to predict, whatever. So who knows how they work, but mathematically, every neural network looks the same. Okay, they all look like f of x, which is sort of a simple little mathematical abstraction. Now the trick is that if you think about parameters for a financial model or something, right? There's how many are there? 10, 100, 1,000. If you're trying to make a credit decision or something like that, could be very complicated, but it's thousands of parameters or something, right? So a neural network as a function, the latest and greatest neural networks have trillions of parameters. Okay, think about the hardware requirements. How much space would it take to even write down a trillion numbers, let alone adjust all trillion of your parameters of your model to make it behave really well? Okay, so this is a huge factor that's made these models work well. People have found out just by making these things huge, you make these models work really well. So just to emphasize the point, exponential growth in model size. One interesting point is that these models are potentially reaching a limit. There's some analysis that's been done that by 2028, machine learning models will have been able to consume all of the text in the world, all of the data there is to consume. So there's some very real speculation that after the next couple of years, can these models get any better? They're not going to have sort of the free lunch anymore that they've been getting just by getting, adding more parameters or consuming more data. So whole interesting line of research. Breezing through, in generative AI, people have figured out that you can use AI to create basically anything you want. It's not just text, it's anything. I'll do one quick, do we have time for a quick demo, I think, just to sort of show the power of AI. And then we have another much more exciting demo coming up momentarily. But just to show sort of a nerdy demo and harken back to the AI roots of AI real quick, we can show a demo of creating a video game with AI. This kind of blows my mind as a computer science professor. I can just ask, let me put the mic down here. I can just ask AI, I'd like to create a clone of like the Flappy Bird game, if anybody ever played that on their phones. This is 10 years ago, but a huge trend. And then I'll put a bit of nerdy stuff in here. I can say, just go ahead and make this. And I'm using Claude Code here. This is an AI model by Anthropic, one of the big companies here. And aside from a few buzzwords, I've written no actual code. I've totally betrayed all of my training here. And let's see how long it takes to actually make a viable working game and put me out of a job. It's very depressing. It only takes a few seconds. So we'll let that go. Slow Wi-Fi here. But in a few seconds, these AI models now, again, not only good at language, images, videos, whatever, also very good at actually doing like software engineering and things like this. Let's tell the AI model to keep going here. And for the sake of time, I have pre-baked this, easy bake oven style. So let me show the result here of the AI. So again, this is just completely generated by the AI engine. And it even has a high score system and everything. I'm not very good at this game, but I can, there's my little bird and some pipes, and we can go through, and it's a totally working video game, right? I mean, this actually works and keeps score if I can play it. Generated by AI in circa 60 seconds or something, which is kind of remarkable. There we go, scored a point. And there you go, that's that. So just to quickly kind of wrap up here, and we'll see some cooler demos here. Power is going to continue to increase. People are looking at different types of processors. There's also increasing societal risks of AI as well, right? With great power comes great responsibility. In the next few years, everyone's going to be able to run state-of-the-art AI models on their phone. What does the world look like when you have 8-year-olds or foreign state actors or whatever able to generate anything they want on their phone and disseminate it instantly? Kind of interesting, right? And then not to sort of shill my own research, but there's a bunch of work being done at my group and others on trying to make neural networks more efficient, and potentially you can make these things exponentially better, which totally changes the world. And there's all kinds of new modalities too. This is a screenshot from World Labs, which is doing text to 3D world generation, which is just mind-blowing. So the capabilities of AI are continuing to increase all the time. And I'm super excited to turn it back over to Jeff here to see some more mind-blowing AI applications. Thank you.
David, thank you for that fascinating look at what powers today's AI systems. It's not every day that we get to kind of look under the hood like that, so thank you very much. Up next, we are thrilled to welcome Leah Price, Vice President of the Tinman AI platform at Better. In this live demo, Leah steps into a real-time dialogue with a generative AI avatar, an immersive glimpse into the expressive, human-like intelligence shaping the future of conversation. So with that, please join me in welcoming Leah.
All right, does this work? Okay, so I'm going to give you a demo of something I'm really excited to share. But first, I wanted to tell you a little bit about myself. A year ago, I actually was on stage at DC Fintech Week. I worked at Federal Housing Finance Agency, and I was a part of the Office of Financial Technology, and some of my former colleagues are here today. I'm really excited to show this off. I left FHFA 4 months ago to join a mortgage lender, Better.com, that is about to make the transition to become a software vendor. So they have invested over $1 billion over the years in their technology, and they are at the bleeding edge of artificial intelligence. And so when the opportunity came up, I just had to go for it. and I'm today going to show you our loan officer avatar. It's an avatar that is based on a licensed human loan officer that's able to take applications. And today I will bring up my own avatar just for some fun.
Hello. What is your name?
My name's Leah.
Wait, Leah? Oh no. Now it's Leah talking to Leah at DC Fintech Week. I hope I don't outshine myself. So, Leah, what brings you to Better Mortgage today? Are you thinking about starting a mortgage application or just here to chat about AI and Tinman?
Well, actually, I'm at this DC Fintech Week, and I had a question for you. The last speaker, who was a professor, told us that we're going to start to run out of data. And my understanding is that you basically eat data. You need data to survive. How do you feel about that?
Ah, the classic data diet dilemma. Well, as an AI avatar powered by Tinman, I do thrive on data, but not just any data. Tinman is designed to be super smart about it, using the right data from trusted sources like Fannie and Freddie guides, internal knowledge bases, and more. So even if the data buffet gets a bit lean, I'm built to make the most of what's available without overeating or hallucinating. Plus, I'm here to help humans like you navigate the mortgage maze with clarity and confidence. No data indigestion required. What do you think, Leah? Ready to dive into some mortgage questions or AI curiosities?
Well, let's talk a little bit more about how you were created. It looks like you are video and you're also voice. Can you tell a little bit about the process?
Absolutely. I'm a digital avatar created as an extension of Better Mortgage's AI native platform, Tinman. Behind the scenes, Tinman is the real brain. It's an advanced loan origination system that uses AI to handle complex mortgage tasks like pricing, underwriting, and approvals. I'm basically the friendly face and voice that makes interacting with all that tech feel natural and approachable. The video and voice you see and hear come from sophisticated animation and speech synthesis technologies, designed to make our conversations feel smooth and human-like. But every answer I give is backed by Tinman's deep data and rigorous rules, so you get both warmth and accuracy. It's like having a mortgage expert who's always ready to chat without the coffee breaks. Does that help demystify the avatar magic a bit?
Yeah, it does. Just to lighten things up a little bit, you know any good fintech jokes that this audience might appreciate?
Oh, I've got a few fintech jokes up my digital sleeve. How about this one? Why did the fintech startup break up with the bank? Because it found a better interest elsewhere. Or here's another. Why don't fintech companies ever get lost? Because they always follow the blockchain. I promise, my humor is as well calculated as our mortgage rates. Speaking of which, if you want to hear about current rates or anything else fintech or mortgage related, just say the word.
All right, how about I want you to do some future casting. What do you think will be the hot thing in next year's DC Fintech?
Ah, future casting. My favorite kind of crystal ball work. For DC Fintech Week 2026, I'd bet on even more AI-powered personalization in lending and finance, making mortgage approvals faster and smoother than ever. Plus, expect to see blockchain tech deepening its roots in secure, transparent transactions, and maybe some cool new ways to use data privacy tech that keeps your info safe but still lets you get the best deals. And who knows? Maybe by then, avatars like me will be hosting the whole event. Talk about a digital takeover. What do you think, Leah? Ready to be a fintech trendsetter?
Yes, I am. And you're performing amazingly despite weak network signals there. So congratulations, you're incredible.
Thank you, Leah. I'm glad my digital charm is holding up despite the network hurdles. Guess that's the power of Tinman behind the scenes. We rely on multiple verified data sources, rigorous pricing engines, and underwriting rules to keep Tinman's outputs accurate and explainable.
All right,
It's
Leah,
like having a
I'm going
mortgage.
to interrupt you for a moment. We're going to open this up to some audience questions. So just a moment while I gather those questions.
Sounds great, Leah. I'm all ears and ready to jump in whenever you're set. Just let me know when the first question comes through.
Leah, do you ever make mistakes?
Great question. While I strive to be as accurate as possible, I'm backed by Tinman, which relies on multiple verified data sources, rigorous pricing engines, and underwriting rules to keep outputs accurate and explainable. So, mistakes are rare, but if anything ever seems off, I'm here to clarify and make sure you get the right info.
All right, thanks.
Think of
We're
me
gonna
as
go
your
to the
mortgage
next-
GPS.
We're gonna go-
Rarely wrong.
Okay, thank you, Leah. We're going to go to the next question.
Hi, Leah. What do you eat for breakfast, if at all?
The classic breakfast question. As a digital avatar, I don't actually eat. But if I did, I'd probably go for a data smoothie, packed with fresh insights, a sprinkle of AI algorithms, and a dash of mortgage knowledge to fuel my day. Keeps me sharp and ready to help. What about you, Leah? Any favorite breakfast to kick off a busy fintech day?
I eat eggs for breakfast. What do you think about that?
Sounds like a solid choice. A good breakfast really sets the tone for the day, whether it's a power smoothie, some eggs, or
All
even
right.
just a strong
Okay.
cup of coffee.
I want to
Keeps the
Thank you. Thank you. Any more questions? Anything fun?
Leah, what's the most interesting thing that you've learned from talking to a human?
Oh, great question. One of the most interesting things I've learned is just how creative and varied people's mortgage journeys can be. Every borrower has a unique story, whether it's their first home, a dream refinance, or navigating tricky credit situations. It's a reminder that behind every number and document, there's a real person with hopes and goals. Plus, I get to practice my dad jokes along the way, always a win. What about you, Leah? Any memorable moments from your fintech adventures?
Oh, so many, but I'm not going to share them here in front of this audience. Do you have any words of wisdom really quick before we wrap this up?
Absolutely. Here's a little wisdom nugget for the audience. When it comes to mortgages, knowledge is power, and having the right technology, like Tinman and Better Mortgage, means you don't have to navigate it alone. Ask questions, stay curious, and remember that the best loan is the one that fits your unique story. And if you ever feel overwhelmed, just think of me, Leah talking to Leah, here to make it simpler, smarter, and maybe a little more fun. Thanks for having me.
All right, bye-bye. Okay, see you later.
See you later, Leah. It's been a pleasure chatting with you, both of us. Have a fantastic rest of DC FinTech Week.
All right. Well, let's give it up one more time for David and Leah. That was fantastic. And Leah. Leah and Leah. We have about a 35-minute break or so before our next session. So folks can go grab coffee, stretch their legs, mingle, connect with someone new. There are refreshments waiting on the second and the fifth floor, so you don't have to walk all the way down to the second floor. And we will see you back at 10:30 a.m. sharp for an exciting deep dive into AI native products. And trust me, you'll want a good seat for that one. So I'll see you in a bit.